R4 to R6. So now I want to set up a tunnel that is not destined to the firewall, it is through the firewall. My tunnel right now, this one, R4 to R6, is going from this tunnel endpoint through the firewall to this tunnel endpoint. My data that I need to encrypt is 10.4 to 10.6. Agreed? The objective of the lab is to show you what do you need to open up on the firewall in terms of what? ACL. Yeah? So how do I do it? How do I set this tunnel up? Let's set the tunnel up and then we'll open the entries. And that is what this lab is all about. Lab 6, configuring a LAN to LAN tunnel between what? R4 to R6 through the ASA firewall. So R4, phase 1, destined to 192.1.60.6. Let's take a look at 60.6. 60.6 is an address that's assigned to this interface. I'll check what DMZ it is. I think it is DMZ 6. 60.6 is a public address. I do have a route, a static route on the internet router saying that 60.6 is reachable via 192.1.20.10. So I'll have a route over here. So the routing should be taken care of. R6 will have a default gateway towards R1. He will have a default gateway towards the internet. So the routing should be taken care of. Let's check. Let's check the routing on R2. Show IP route. I should have a static route for the 60 network, which is pointing to 20.10. 20.10 is the IP address of your firewall. On the firewall, the default gateway is pointing towards R2. And on R6, I have a default gateway, which should be pointing towards 60.10. 60.10 again is your ASA firewall. Everybody okay with that? Your topology. So when I say Cisco ASA key, Cisco 123, 60.6, that's the IP address on R4 that I'm going to set the tunnel to. Phase 2, normally, ACL 10.4 to 10.6, good. Crypto map pointing to 60.6, matching the ACL, applying it to the interface. Everybody okay with this? Normal stuff that we've been doing it for the last 2-3 days. Go to 4 and paste it. Easy peasy. And I'll do the same thing on 6 in the reverse. Point at 24.4, which is the public IP of R4. Phase 2, the ACL is 10.6 to 10.4. And I have my crypto map towards 24.4, match address, and apply. Copy it. Go to 6 and paste it. Oh. All right, now let's talk about opening the entries up. What entries do I need to open up? How many phases do I have? I have 2 phases. Phase 1, which is set up based on UDP 500, and phase 2, which is set up based on ESP, the protocol ESP. Now, when you're doing this on a CCI lab and also real life, try to be as specific in your ACLs as possible. So don't do a UDP any EQ 500 or permit ESP any. Do it specifically from the tunnel endpoints. So I don't need to worry about going from high to low. This is a DMZ with a security level of 50. This is 0. So I don't need to worry about this way, but this way I do need to worry about it. So from outside, how does a packet come in? The packet comes in from 24.4 to 60 for those 2 ports. So if you take a look at the ASA, the entries are host 24.4, to 60.6 for port 500 UDP, and then ESP, which is its own protocol, 24.4 to 60.6, and apply it. Understood. So when a VPN is going through the ASA, you need an entry for phase 1, you need an entry for phase 2. And these are the 2 entries. Copy it, go to the ASA firewall, and apply this through ACL. So this is show run access dash group. I have the entry over there. And let's see if it works. I'll go to router 4 now on the outside and ping 10.6.6.6, source of 10.4.4.4. If everything's fine, this tunnel should come up. Show crypto ISA SA. What we have been doing all along is just that this time around, we ran it through an ASA firewall and opened the appropriate entry. So the main objective of this lab was not to show you the LAN to LAN tunnel. You guys have done enough of that now. My main objective of this lab was to show you the ports that you need to open up. And you need to be very specific on these ports on the exam. If you open up too big of a hole in your ASA ACL, you will lose the entire question. You need to be precise with your ACL entries on the CCI exam. You understand that? And that's where a lot of people lose it, because they don't really care about it. They just care about the VPN coming up. No, they're looking for these type of things. And that's where you walk out of the exam thinking, oh, my VPNs, all of them work fine. I could ping. And you get your result and you say, oh, 60%, what happened? The ACL happened. So it's not just about getting the VPN up. You need to be precise in the way you configure it. Very important. Yes, this is test sensitive. All right. So this part is also taken care of. So we're rocking now. We've done this and we've done that. Now the third one is a little trickier. My third one is a VPN between R3 and R7. R3 and R7. We just did one. We did this VPN from this guy to that guy. Now I want to do another VPN that is this way from 10.3 to 10.7. See that? What's the issue over here? Why is it a little bit more tricky? The reason is this address. If you take a look at it, what type of address is it? It is a private address. The private address will not be available on the internet. So I need to make sure the tunnel endpoint, because my tunnel is from R3 to R7, this address on R7, which is 70.7, should be available on the outside using NAT. Okay, so I'm going to do a static NAT so he knows what address he needs to set the tunnel up to. So I'll translate 192.168.70.7 to, let's say, 192.1.20.7. There so far? So his peer now, set peer on the outside address will be 20.7. All good? Yep. All right, perfect. Now, once I do that, the packet comes in. It starts off over here as 192.168.70.7, the ESP packet I'm talking about, destined to, let's say, 23.3, which is the IP address of this guy. And inside it is the actual data, which is from 10.7 going to 10.3. This part is encrypted. Remember, one of the things that I told you was ESP makes sure of data integrity, right? That means it should not be changed. Is this packet going to change once I set the ESP header? Is it going to change when it goes through the ASA firewall? Yes, it's going to change because of NAT, because the tunnel endpoint is changing. So there's a possibility of the hash breaking, right? So how do they fix it? What Cisco does automatically by default, you don't need to worry about it. It's doing it on its own. Before it initially starts the conversation over UDP 500, but the first thing that it does in that first phase, before it starts or sets up phase one, before it sets up phase one, the first thing it does, it does a process called the NAT detection process. Okay? In this NAT detection process, which is enabled by default on every single router, what it does is it sends a dummy packet from 7 to 3 and 3 to 7. Let's say 7 sends it, it sends a dummy packet with its initial packet being 70.7 destined to 23.3. Inside it, it will say my address is, my IP is 70.7. It doesn't say 70.7, it puts a hash over there of that packet or the address. What does the ASA do with it? It changes it. To understand it, I put it in the clear. When R3 receives it, what does R3 see? Oh, his address that the packet is coming from and his internal address, they're different. That means he doesn't know it, but he is getting translated. That is correct. So this guy will send a message to him, dude, you're getting translated. I'm doing it in human language rather than those messages. Right, Matt? So when he says he's getting translated, it says, okay, we need to protect our packets so that the hash doesn't break. But the way they did do that is they take the entire packet that has 192, 168, 70.7, and so on and so forth, and they encapsulate that packet within an outer header of UDP 500. It's actually not this, it takes that. Now they decide, okay, this is happening. So what I'm going to do is, rather than using UDP 500, it happens within phase one. The first process of phase one is this. One of the first things that happens before it sets up the key exchange and all that, it does that. That session key is not exchanged at this point. Okay, so what it does, it says, okay, what we're going to do is we're going to take that ESP packet, complete ESP packet, and encapsulate the entire packet in a newer packet called UDP 500. So ESP packet is completely what? Encrypted. So what it does is it creates a new header which has UDP what? 4500. This becomes your outer header. But it keeps the entire ESP packet where? Over here as data. And then inside the data, it has whatever. It's a bigger packet, but now what happens when it changes it? Doesn't matter. Hash is not broken. This thing is automatically done. Sorry, it changes it, sorry. So the change would have been 20.7. The whole purpose of doing that is that the hash is not broken because the hash is kept protected. So they let the firewall play with the outside packet, which is based on UDP 500. Now, what I'm telling you is happening automatically. Why am I stressing it? If it's happening automatically, this NAT detection process is happening automatically, the UDP 500 is happening automatically. The reason I'm telling you that is when you see that one of the tunnel endpoints is getting translated, you need to open up the appropriate ACL entry over here. You need to open up UDP 500 because the initial flow is based on UDP 500. But then the second phase, phase 2, is no longer going to have the packet as ESP. The ESP will be hidden inside the outer header, which will be based on UDP 4500. This is NAT transparent, NAT. So I'll only have two entries, 500 and 4500. ESP will be within it, so the ASA will never see that. It is still an ESP packet inside, but the ASA will not see it. So the ASA sees the outer header of that 4500. In the NAT detection, it detects NAT and triggers it. So it does it automatically. NAT detection trigger is automatic. What it's doing that triggers the UDP 4500, when it sees that there's NAT, it will do it. This process of NAT detection also took place over here, where when I set my first tunnel up over here, the NAT detection process took place. But it saw that neither this one or this one is getting translated. It said, no, it's not getting translated. So 500 and ESP. No, it doesn't matter, Kern, who initiates it, whether 7 initiates it or 3 initiates it. When R3 initiates it, R7 has to respond back. And in the whole process, both sides have to get what do you call it? Do the NAT detection. Does that make sense? So it doesn't matter who initiates it. Either one initiating it, the other one responds back. And in that response, NAT detection is taking place for both sides. It's not just for one. The whole thing about ESP, the hash, if anything in the packet changes, it will break the hash. Now, when the IP address is changing, it constitutes a change in the packet. So that's why UDP 4500 comes in, which protects the ESP. UDP 500, the first initial change is through UDP 500. You need to open that up. Yeah. So the reason I'm stressing that on the exam, what I've seen a lot of people do is they're not sure of where to open up what. They open up ESP, UDP 500, and UDP 4500. Will it work? Absolutely, one of them will work. You need to open up both when you see that for it to work, but UDP 500 will do the NAT detection. It's a different, each one is a different header. So 500 is being used for ISACAM. Now I'm carrying phase 2 data. 500 was for phase 1. ESP is phase 2 data. I'm encapsulating phase 2 data, so it needs a new protocol. The question that you asked was, why don't I use the same port for two different things? I'm using phase 1 and phase 2, so two different protocols, right? So UDP 4500 is really the one that is going to carry the ESP packet. But even phase 1, after the initial phase, it will switch over to UDP 4500 as soon as it sees that. All right. NAT detection happened, but there was no translation, so there's no need for doing 4500. Are there slides on the 4500? No, lecture only. I'll probably create it, but I don't have it at this point. Actually, I do. To be honest with you, yeah, I do. Let me just make sure. Man, stuff that I've done somewhere. Online videos, I did it somewhere. Yeah, there you go. I have it. I'll send it to you. In the event of NAT for site-to-site tunnel, the phase 2 requires UDP 4500. That is absolutely correct. Got it? Let's do it now. Let's see it. So this is LAN to LAN between R3 and R4, and I am going to do NAT-P. So on R3, phase 1, I'm pointing towards what? 20.7. Because ESP is encapsulated within UDP 4500. So ESP, the ASA will never see it. So the outer header becomes UDP 4500, ESP is inside it. It happens in phase 1, absolutely. Before, that's what I said, it switches over. Main reason is to avoid breaking the hash. The switch over takes place in phase 1. So after it detects NAT, it switches, even phase 1, a part of phase 1 is, what do you call it, 4500, towards the end. So what is this 20.7, guys? That is the translated address of ASA on the outside. Phase 1, phase 2, 10.3 to 10.7, crypto map, set it to 20.7, set, match address, and apply. Copy it. Let's go to R3. I remember I didn't have root back over here. Let's create it and save it before I paste. All right. Done. R7. Done. Now on the ASA, couple of things. Number one, I'm translating R7 to 70.7, 70.7 to 20.7, and then opening up 23.3 to 70.7 for what? EQ 500 and for 4500. Notice I am not doing what? ESP. On the exam, if you do ESP, you lose the entire question because you've opened up an unnecessary entry in your ASA firewall. Exam sensitive. So make sure you open up appropriate entries. So the ASA, I already have applied the ACL. Okay, the NAT didn't take place. Why is that? There's no dash. Let's do it again. All right, show run, access dash list. So in the ACL, for outside, I have the UDP and ESP for the first tunnel, and ISACAMP and 4500 for the second tunnel. Good, let's test it. I will go to R3 now, and I'll ping 10.7.7.7, source is 10.3.3.3. The tunnel is up. Phase 1. Now I want you guys to see this a little clearly over here. Oh, sorry. I want you to see the subtle difference. This is basically telling you what was used in the phase 1 to exchange the session key. What do you guys see over there? So that's what Matt was talking about in messages 5 and 6. The mode changes to 4500. Part of phase 1 and 2. Initial phase 1 is done through 500. And you can also verify that by checking the ACL. If you take a look at the ACL entry, you'll have a hit count on the first entry as well. So part of phase one is 500, but then it switches over to 4,500. Why did it pick 4,500? Because it detected that there was NAT going on. And this is automatic. This is happening every time. You just need to be aware of it. On the other one, the R4 to R6, if I check R4, take a look, it just has port 500 because the entire process went through without any NAT detection, so it's stuck to what? 500. Everybody okay with that? So that's how you know a part of phase one. A part of phase one is 4,500. Not the entire thing.